Hi everybody, welcome to the channel. So today we are here to discuss one of the very important concepts in the .NET part, that is called Explicit Interface Implementation. So whenever we try to implement an interface in a class, there are two ways. Either we can have it as an implicit or as an explicit. In most of the cases, what we see is like it's always implicit interface, but there are some specific cases where it could be an explicit interface as well. So we'll see like what are those cases where explicit interface is required, and there are some concepts that are being involved around this part, like why it is and how it is. So that is what we are going to discuss. So this is important in terms of from the understanding perspective. Also, this is one of the very important questions that is being asked in the start and mid level of interviews across the industry. So let's begin. So we have the Visual Studio and we'll try to do a very simple use case. Let's try to add an interface in our application. And let's call this interface I file logger. So once we have this, we can have a method over here. Let's call it void log entry, and it takes a string which is the message and does the work. Now what we have is we have an implementation of this interface. Let's call it file logger, and what it does is basically it implements the interface, and we have a method over here. So we can just say console.writeLine message. So it could do whatever we want it to do. It could write to a memory stream, or it could write to a file or a persistent storage, also it wants it. So basically, so this will work fine. So the implementation that we are seeing over here, it's basically implicit interface or implicit implementation. The reason being, we just refer to the name of the method directly from class. And as we all know, all the methods that are being defined in the interfaces, these are all public methods. So likewise, whatever methods that we have in our implemented class, that needs to be all public by default. So now coming to our program.cs, here we can directly invoke the interface, or we can do it at class level as well. I'll quickly walk through both. So I can have something like this, and I can do log entry. Okay, and I can also do something like this, and this is also a very valid case. And what this will do is like it will just raise $b dot entry from concrete. So if we try to quickly run this, we will see both the instances or both the log entries directly from there. And here we go. So we have both the interface and the concrete. So it works well. That's fine. Okay, so let's take another case. We have a system where we need to have audit in our system. Audit is basically like the audit trail where we have the details of all the methods or all the stat, like whatever we do operations. So I'll quickly add that interface in my solution. And what we'll do is like we'll go with the standard process. We'll go over here, we'll write and I audit logger. And so both of these interfaces, the I file logger and the I audit logger, so both of these are separate interfaces. So within themselves, they can have the same method and with the same signature, like this, something like this. Yes. So we see it is the same. Now let's say there is some weird requirement. Ideally we should try to have a single responsibility in most of the cases where the classes should not be driving any such conflicting areas, and those implementations should be limited to the specific classes or specific areas. It means like there should be a separate class or an abstraction over the audit part, and likewise similarly for the file logger. But let's say assuming there is a very weird requirement, and what we need to have is we need to have both the file logger and the audit logger to be implemented in this class, and let's just call it a simple logger, something like this. Okay, so now this is my generate logger, and what it will have, I would need to drive I audit logger as well. Now the problem will come, the reason being both of these interfaces. So even if I go with there is a void log entry string message, and if I go with the other one, the same message, void log entry message 4. So let's try to build a solution and let's see what happens. So okay, the solution builds fine, and if we try to run it, we also see like there is no error or something around that. But the problem was a bit different over here. The problem was we need to have dedicated implementations for both the interfaces, and for that, what we need to do is like we need to have a explicit implementation. So we need to define the name of the interface over here, like this, and let's just call it again over here like this, and I'll add some details over here just to identify which part it is, something like this, and I also add for this one something like this. So with this way we should be able to identify which of the implementations. One more thing to note is like as soon as I apply this, so till the time it is there it was getting me an error, and as I apply this I put the audit log, basically a fully qualified name of the interface, and at that point of time this error goes up, so my class. But there's another problem over here. The modifier public is not valid for a explicit interface implementation. So what this means is like right now we are having this explicit implementation that is basically, in simple terms, if we say, is to have the name of the interface as well on the implementation part, and with that we cannot have the public modifier. So to compile this code, what we need to do is something like this. So this is one of the major caveats that many people fail to identify. They know like we have to do the explicit implementation where we have to provide the implementation name, but they don't actually recognize that we have to remove the public keyword as well. Now the funny part is like you see, as soon as I do that, this log entry method is not available, and the reason is like I cannot access a private method log entry. Okay, that's fine. So how do we access that? Well, if you see the I file logger, the first method where we are trying to access it via an interface, there it is not giving any error because this method is available, this log entry method, this is available on the interface, and we are actually trying to invoke this method on the interface, not on the instance. But if we go through the second part on the second set of lines over here, basically what we are doing is we are trying to invoke this on the basis of a instance, so that will just not work. So to update that part, what we can do, we have the instance, and let's say if I want to invoke the other part from the I audit logger as well. So what I'll do, we can do something like this. Or let's use the complete naming. I audit logger equal to, we can do something like this, and sorry, my bad. This is a perfectly valid, and then we can call audit logger dot log entry. So I'll just put it from, and let's try to run this. So you see over here, what happens is we are basically again, so this instance has the interfaces for both I file logger and I audit logger, so it can be cast into either of these ones. And the way we are doing it is like we are trying to invoke this from the interfaces, not from the instances, and that's why it works out. And if you want to go like what is the exact reason why this happens, so for that part we have to jump into the C# specifications. These are a bit older one that I could capture immediately, but again if we go through that solves the purpose, it provides the details, and I'll quickly zoom into it, and here it is. The explicit interface member implementations have different accessibility characteristics than the other members. So basically what this means is that if we are any of the members log entry in our case, so they'll have a different accessibility than any of the other public or private methods. Now why it is, that is explained in the next line. Because explicit members invocations are never accessible through their fully qualified name in a method invocation or a property access, they are in a sense private. So what this means is basically what we saw over here in the program.cs, it was giving us an error over there. So that is exactly what it is saying. So they are in a sense private, they are not accessible with a fully qualified name. Now when we say a fully qualified name, I'm assuming that most of you know this. Just in case you don't know this, the fully qualified name is your namespace, then a dot, and then a logger. So in this case, if I say, well, like what is the fully qualified name for this one, that would be interface test dot logger, something like this. Yeah. So this applies for everywhere. Okay. Now let's move to the next part. However, since they can be accessed through an interface instance, they are also in a sense of a public. So this is very interesting part. Somehow it's like they are both private. When we try to have them from the instance part, from the instance to be if we speak in a very simple terms, but if you try to do that from an interface, it's a public one. So now the next two statements also define the purposes. Because explicit interface member implementations are not accessible through class or struct instances, that is the instance of a logger in our case, they allow interface implementation to be excluded from the public interface of a class or a struct. So we don't need to have the public part, public interface of that part. This is particularly useful when a class or a struct implements an internal interface that is of no interest to a consumer. So this is again from a accessibility perspective. Let's say I have an interface which I am using within my class or within my assembly rather. So in that case, what would happen if I don't need to expose this interface outside of my assembly? In that case, what I can do, I can simply have these explicit implementations, and in all such cases wherever I need to access, I can use that interface to access that. Otherwise I don't need it. So this is one of the use cases that I was trying to set in the start of this session. And the next part is explicit interface number implementations allow disambiguation of interface members with the same signature. So this is what we did. So we have two interfaces which have exactly the same signature, the same method name, and the same number of parameters, and same type, of course, to match the signature. And to have the disambiguation over that part, we use this. Without explicit interface implementation, it would be impossible for a class or a struct to have different implementations of our interface, which is the same signature and return type. And it should be impossible for a class or struct to have an implementation of all the interface members with the same signature, but with a different return type. So that makes it all. So these are the reasons why it is not technically possible. Why whenever we have to create the implementation as a private one, because for a class level, from an instance, it's always private. It's not allowed from there. But from the, if we go or if we traverse or invoke via interfaces, then it is available over there. So guys, hope you liked it. If you have any of these queries or comments, just please post in the comments down there, and we'll try to answer that. Do let me know in case you have any other pointers or any other areas that you like to go through, and we'll keep up these conceptualization sessions, and that will also cover some of these interview topics that are being asked from the depth perspective. Thank you. Have a great day.